Hi everyone, I'm Candy Hua. Today, my presentation topic is quantum chemistry. Chemistry is a typical subject that is based on experiments. All its results, theories, and achievements gradually form a part of the elementary concepts. And the target of the quantum chemistry is to understand these concepts, to solve each mystery of atoms, molecules, structures, and so on. In the year of 1927, quantum chemistry was still called theory of valence. It once included some very fundamental problems, like why do molecules form, and what is the origin of the stereochemistry of molecules. The investigative process of trying to solve them finally formed quantum chemistry. Through the passing time, it becomes an excellent tool in different branches of chemistry. It is also used to obtain information without direct measurements. Molecules is an item that can be described as the largest part of chemical substance. In accurate definition, quantum chemistry is an academic subject that studies molecules and processes substance involving molecules by using methods of quantum mechanics. Harry Irwin, John Walter, George Kimball had written a text on quantum chemistry. It said, "As quantum mechanics is correct, chemical questions are problems in applied mathematics. The quantum mechanics become desirable. It can lead to an explanation of main features of complex atomic systems without too much computation." In the history of chemistry, there were three scientists who made several indelible contributions to quantum chemistry. Their names are Niels Bohr, Ernest Rutherford, and Max Planck. We can find their achievements in the concept of the nuclear atomic model in our grade 12 chemistry textbook. Their theories and discoveries were the foundation stones in quantum chemistry. The Rutherford model is a model of the atom devised by Ernest Rutherford. That physicist and chemist left a great present for the history of quantum chemistry. He directed the famous gold foil experiment in 1909. We can open the page 121 of textbook and see the whole concrete process of that experiment from figure 3.4. Soon in 1911, Rutherford got his new model for the atom. Based on the experimental results contained the new features of a relatively high central charge, concentrated into a very small volume in comparison to the rest of the atom, and with this central volume also containing the bulk of the atomic mass of the atom. This region would be named the nucleus of the atom in later years. A little time before this model formed, in the early 20th century, the first assumption of quantum theory was done by Max Planck. Planck tried to find the reason for radiation from a glowing piece changed in colors from red to orange and to blue as its temperature rose. He found that energy exists in individual units as the same way that matter does, rather than just as a constant electromagnetic wave. He wrote an equation to represent these individual units of energy, the quanta. He won the Nobel Prize in Physics because of this discovery in 1918. On page 123 of textbook, we can see an image of the electromagnetic spectrum and its properties. Actually, Max Planck originated the problem of atomic spectra. When different elements are vaporized in the flame, they each produce a unique spectrum. But why does this occur, and where does this energy come from? Niels Bohr, the Danish physicist, combined the ideals of a Rutherford planetary model with a nucleus and circling electrons, and Planck quantized the amounts of energy. He concluded that the energy of the electrons in an atom has to be quantized. This meant that electrons could only have certain amounts of energy. As we learned in section 3.2, the Bohr model established the concept of definite electron energy levels within atoms. But Bohr's model was rather simplistic, and as scientists made more discoveries about more complex atoms, Bohr's model was modified and eventually was replaced by a more sophisticated model. The quantum mechanical model of the atom presents a more accurate model of the atom. It is a more sophisticated model based on complex mathematical calculations and interpretations. It introduced the concept of sublevels, SPDF, and atomic orbitals. According to calculations in quantum mechanics, each energy level of an atom consists of one or more sublevels. N equals the number of sublevels in the nth principal energy level, where n is the principal energy level. These are some examples. These knowledge are elaborated on page 134, the first and second quantum number part. Each sublevel has one or more atomic orbitals with a specific three-dimensional shape. The shape says the atomic orbitals are related to the probabilities of finding the electrons in a certain volume in space. Using the Cartesian coordinate system, x, y, and z axes, as a frame of reference, the nucleus of the atom is located at the origin. On page 137, the text and the diagram of shapes of orbitals can explain this well. In 1991, Richard Ernst developed the 2D nuclear magnetic resonance spectroscope. In the modern period, most of the chemical experiments rely on this technique because it is most widely used. It can work for absorption, emission, or electromagnetic radiation by ions, molecules, nuclei, or atoms. Now the quantum chemistry is a mature science. There are two active major developments as modern chemistry working in the quantum field: the development of new methods of quantum mechanics and the algorithm for calculating the chemical properties and the definitions of new concepts for the interpretation of chemical problems. The development of new quantum mechanical problems such as magnetic fields, laser, and molecular beams gradually relies on the modern techniques. For example, some problems of quantum chemistry are too difficult to be used without computers. The human never stops their discoveries. They follow the steps of the time but also try to break the control of the time. They plow into the science as deep as they can, like the quantum chemistry, which never stops the evolution. And absolutely, the continuous feedbacks between experiment and theory would be a strong indication of the importance and vitality of quantum chemistry in the future.